Hello and welcome to another walkthrough. Now this time it will be Edexcel Applied Math Paper 2-1 Statistics and Paper 2-2 Mechanics, May 2025, which I have never seen before. So this is going to be a blind solve for the entire paper under the real exam conditions. So along the walkthrough, I might be making mistakes, which I'll correct if I realize in the walkthrough. But if I don't, I'll annotate the video and I'll try to explain the worked solution and the thought process as simply as possible. At the end of the walkthrough, I'll mark the paper anyway. For those of you who make mistakes a lot of time, you might benefit from seeing me making a mistake and correct it later. So this walkthrough is not meant to just show you the destination of the solutions, but also show you the journey to the destination. If you feel like jumping to a particular question, you can use chapters in the description. Otherwise, stick around. You might be getting some tips along the way. If you are ready, I'll see you in there. Hi guys, just a quick one here. This statistics always blows my mind. So as you can see, for the past 28 days as of today, out of all the 7.7 thousand watch hours, more than 90% of those watch hours come from those of you who aren't subscribed to my channel. And that gives me an urge to beg you, please help support me by subscribing the channel. I will return this huge favor by creating more and more videos. I'm going to utilize my teaching experience for 10 plus years to create the videos covering tips and tricks and the hard bits in the topics that most students struggle to understand. It can either be a short video, a long video, but they will sure come up. So that is why you need to subscribe to stay tuned. I hope we have a deal. Let's get back to the walkthrough. So here's the statistics paper. We're going to start with it first and then followed by the mechanics paper to come later. And I'm going to start the timer now. Okay, let's go. Going to write in here on the right side. Number 1. The random variable x modeled as binomial trials 20 and probability of success 0.37. Part A, find p x equals 8. So there's no problem there. That should be easy. The probability in binomial distribution, you just use the formula px equals 8. So that's going to be n, which is 20, yeah, and let me just write down here, and 8, right? So NC8 here, this is the binomial coefficient, and then the probability, which is 0.37 to the power of 8 times 1 minus that probability, and this is so-called probability of maybe failure, okay, to the power of 20 minus 8, which is the remaining there, because remember, these two powers add up to 20. That's it. That's easy peasy, I guess. Just going to do a calculator there for that. Okay, so it's 20C8 there, isn't it? Times 0.37 to the power of 8, and then times 0.63, isn't it? Yeah, to the power of 12. Right, so that's the answer there. 0.172. Let's do 3 decimal places, yeah, or 3 significant figures in this case. Same thing. All right, so that's the answer to the first part. Let me just double check. Yeah, that's fine. Part B. Find probability of x less than equal 5. Well, in your calculator, a scientific calculator, hopefully, a graphing calculator, you should be able to do binomial CD there, and you're going to have to plug in n equals 20, probability of 0.37, and there is an x there you need to plug in. Just try it, and in this case x is 5. Okay, I don't have that graphing calculator, so what I'm going to do is, let me just check if there is the binomial table in the formula sheet. Yeah, there is. Okay, so I can tell you how to use that. So let me just show you the formula sheet. If you go to statistical table, binomial cumulative distribution function here. So we're going to pick n20. So you go, this is n5 and 6, yeah? So you go to n20. And then, oh, no, I can't do this because there's no probability of 0.37. Okay, but the calculator can do that. So in this case, I'm going to use a Desmos calculator. But there is a way out as well if you don't have the graphing calculator. So you do p of x equals 0, x equals 1, 2, 3, 4, 5, and then you add them up. I might have done that in other walkthroughs. Probably not going to do it here, guys. Yeah. So I'm going to use a Desmos calculator, which I already prepared that here. Okay. So in a Desmos calculator, if you don't have a graphing calculator with you, you can just do function here and go down to probability distribution, right? And then binomial distribution here. And then they're going to ask you to put trials and success probability. So trials in this case is 20. Whoops, 20. And comma 0.37, yeah? And then you're going to toggle down this thing, cumulative probability. So we do left, right? Because that's less than 5. So left here. So just put 5 in there. You're going to get a probability there. Okay, so that should be the answer, guys. So it would be 0.91191. Yeah, so that would be the answer. Just that. That's all they need you to do. Just write down the answer. And then find the probability of that. Okay, so that's weird now. It's just ask you again using the same distribution and the same number there. Calculator work, right? We just changed that to 5.7, no? Okay. I almost fell for that. This is discrete distribution. So there is no 5.7. If you put 5.7 here, let's see. It's going to give you the same number. Because less than equal 5.7 means less than or equal 5, because there is no 5.7 in the distribution because it is discrete. So there's just 1, 2, 3, 4, 5, 6, 7, 8. So less than equal 5.7 is the same as less than equal 5. So we write the same number there. Okay, that's number 1 done. Ooh, number 2, longer one, indeed. Number 2, Jasper is investigating the relationship between daily mean pressure and daily mean wind speed. This is large data set, okay, for Perth in 2015. Perth is in Australia. Okay, using the data from large data set, treating the large data set for Perth in 2015 as the population. Right. Jasper decides to use all the data available. Write down the name given to this method of data collection. Right. So okay, this doesn't require the knowledge of large data set, but is the general knowledge of statistical sampling. Yeah. So this is about sampling. Hang on. So use treating the large data set for Perth in 2015 as the population. Decide to use all the data available. Okay. When he decides to use all the data available, this is called census, not sample. So when you treat something as a population, and let's say you want to find the mean, in this case mean whatever, daily mean pressure, mean of daily mean pressure. You want to find the mean of the pressure in every day. And because he is treating the all available data as the whole population, and he is going to use all that, that means he is going to take all of the data and find the mean. This is called census, right? So census, like this, I hope I didn't misspell that. Yeah. Which is the opposite to sample. So census is taking every member in the population versus sample just taking some members in the population, right? And as you might know, it's more expensive, it's more time consuming. Imagine you need to ask, let's say you want to find a mean height of a population. You want to go ask everybody in the country what would be their height, and then find the mean. So that would be time consuming, right? Census. Okay, that's the answer there. All of the daily mean wind speed data for Perth in 2015 are classed as either light or moderate. Jasper splits the data for Perth in 2015 into light days and moderate days and draws a box plot for each set of data, but omits the lower tail for light days. Okay, the smallest 3 values of daily mean pressure for light days for Perth in 2015 are 1007, 1009, 1010 hectopascals. An outlier in the first quartile is defined as any value more than 1.5 interquartile range below Q1. B. I. Determine if there are any outliers in the first quartile of daily mean pressure of light days. Alright, so, well, we have a box plot here, right? Let me zoom in, yeah? So this is Q1, yeah? So Q1 of light day is, what's that? This is 15, this is 20. So in between here, this is 16, 17, 18. So that's 2018, sorry, 1018 hectopascal. And Q3, right? We need to find Q3. So Q3 is exactly 1025 hectopascal. That means IQR, right, is equal to Q3 minus Q1 equals, that's just 7, isn't it? Yeah, hectopascal. Because the IQR is 7, that means the critical value below which we have an outlier would be Q1 minus 1.5 times IQR. So that is equal to 1018 minus 1.5 times 7. Okay, so hang on, let's do this most. Okay, what was that again? 1018 minus 1.5 times 7. That is 1007.5. So this is the critical value below which we have outliers. That means 1007 would be the outlier. Yep. Therefore, 1007 hectopascal is an outlier here. And the only one. Yeah. Only one. Right? For the lower tail there. Part II. Hence, complete the box plot of the daily mean pressure for light days. Let me see if they have any. Okay, they don't. So we need to. I need to copy this diagram if you don't mind, because I'm not writing in the paper here. Okay, so I'm gonna put it here. Yeah. Let's see that. Okay, here we go. All right, so we're gonna add all the datas. Okay, so what do we have? I'm gonna use blue here then. Well, so that means if 1007 is an outlier, we have it around here, yeah. So this is 6, this is 7, and then we have on this one, that's an outlier. And the actual minimum will be 1009, which is around here, yeah. So this is 9, and then you go up there. So this you would have the whisker, which is like the bounds, and then everything will just be in there. There you go. All right. So that is basically it. Yeah, for this whole thing, because they already have the higher end. Do a box plot, but almost the lower tail. Yeah, we already have the higher tail, so that's done. Okay. The box plot for light days is based on the data for 161 days. Yeah, so, large data set, so they do from May to, if I'm not mistaken, May to, is it like October? Yeah, May to October, right? Yeah, that's about 161 days. C, using your knowledge of the large data set, estimate the number of moderate days with the daily mean pressure of 1028 hectopascals and higher in the large data set for Perth in 2015. Interesting. Let me just read the question again in my mind. The number of moderate days. So light days means light pressure, right? Wait, hang on. What does moderate mean again? Okay, all the daily mean wind speed data are classed as either light or moderate. Okay. So interesting. Wait. Okay, so it's May. Wait, hang on. Let me just think about the dates, the months. It should be from May, to October, right? Yeah. So what do you have? 5, 6, 7, 8, 9, 10. Let's see. So May is 30 days. No, 31. June 30, 31, 31, 30, 31. So if we add all that, we get, okay. So I'm just thinking that if we try add these up, they're actually, yeah, they're actually more than 161 day. Okay, so 31 times 30 times, so hang on, plus 31 plus 31 plus 30 plus 31. Is that right? 31, 30, 31, 31, 30, 31. Yeah. So this is all add up to, they all add up to 184, right? That means we just do 184 minus 161, because that should be the remaining days, right? The large data set is from May to October. I mean, I might remember this wrong, but I believe if that is the case, then we just subtract 161 from all the days. And I think, isn't that it? Using your knowledge of large data set, estimate the number of moderate days with the daily mean pressure of that, and higher in the large data set for Perth. Yeah, so that's the answer. Yeah, I'm just gonna take my chances here. I'm not sure if this is right, honestly, but if this is right, it's okay. I think you should see the annotation, right? Okay, so I'm gonna leave it at that and go to the next question. Okay, so let me just close that. Yeah. Number 3, bag contains red counters, green counters, and white counters only. The table shows the proportion of each color of the counter that Elsa believes to be in. Elsa selects at random 40 counters from the bag at one at a time with replacement. So taking one out and replace it back in. Yeah. So the total number of the counters doesn't change. Assuming Elsa's belief is true, what does she believe again? Believes to be in. Okay, yeah, so we're going to assume this is the right proportion. Find the distribution of the number of red counters. Elsa selects. Find the distribution of the number of red counters. Elsa selects. Right. Okay. So this is finding the probability distribution, if I'm interpreting this correctly, yeah? So we're going to do R as number of red counters. Okay, so we're going to do R here, and P R equals R. So there is a chance that she will not get any red. That's 0 red, because she selects how many times here? One at a time with replacement. Wait, hang on. Oh, 40 counters. Oh my god. 40 counters? Find the distribution of number of red counters Elsa selects. Alright, first thing first, we need to find the proportion first, right? Okay, that's the first thing we can do now, I think. For part A is to look, this is just basically probability. If P is the probability of red, then 0.2 is the probability of green, which is 20%, and 4P is the probability of white. So P plus 0.2 plus 4P would have to be equal to 1. We know that for sure. So here we have 5P plus 0.2. I subtract 0.2, I get 0.8 here. And then P would be equal to 0.16, right? Yeah, okay with that. Now, I mean, am I overcomplicating this? Does it ask for the probability distribution for number of red counters? Oh, I see. So it's just the expected number, I think. So number of red counters the expected number at least would be just 40 counters times 0.16. I think that's what it wants. Yeah, at least I'll know later, not now. 6.4, that's the distribution. Okay, we don't get an integer, right? Let me double check the math up there again. 0.85 divide, yep, 116, yeah, that should be fine. We multiply that by 40. Yeah, okay, I'm gonna go with that, right? So that's 6.4. Okay, I'm gonna go with that, I think. Okay. Part B, Jada believes that the true proportion of green counters in the bag is greater than 0.2. She takes a random sample of 40 counters, okay, from the bag, one at a time, with the replacement. Same thing. There are 11 green counters in her sample. BI. Use a suitable test to assess Jada's belief. You should state the hypothesis clearly, use a 5% level of significance, and state the p-value for the test. All right. Okay. So this is hypothesis testing using binomial, right? So because she believes that the proportion of green is greater than 0.2, so that means we're gonna do x modeled as binomial first, and this will be 40 number of trials, 40, and then the probability of green, because we talk about green here, so it should be 0.2, right? And because Jada's belief is this being greater than 0.2, so the null hypothesis is the assumption. We have to assume that p is 0.2 first for the green, and the alternative would be p greater than 0.2 because she believes that, right? And then, yep, so we're gonna find the probability. So the way you test hypothesis using binomial here, because her sample says that there are 11 green counters, and because this is testing whether it is greater than 0.2, so we need to do p, we need to find the probability of x greater than, yeah, x greater than 11, yeah, greater than 11, and we find the probability of that. Okay, so we find the probability of this, and basically if you do in the calculator, you should find 1 minus p x less than equal 10 instead, because the calculator can't do the higher tail of the binomial there. All right, and I'm gonna have to be fair, so I'm gonna do the lower tail as well in my Desmos calculator, of course, and you should do in your graphing calculator. So we already have here the binomial, so I'm just going to do 40 here instead. Hang on. Nope, not that. Delete. 40. Probability of success is 2. And then I'm going to do left tail as well, and I'm going to put 10 in here. Okay, so to get the actual value, it's 0.83923. So if we do 1 minus that, using a calculator. Okay, so 1 minus 0.83923. 0.16. I'm gonna do 0.8 maybe, yeah. And 0.161. And this is the probability of x being greater than 11, right? Using this distribution, and clearly 0.161 is greater than 0.05, which is the significance level here, 0.05. Okay, so that means the null hypothesis here will be accepted. So null hypothesis is accepted because it's not less than the level of significance. So that's the way to go, right? So there is sufficient, okay, not sufficient evidence. Yeah, we just write what we should here. Not sufficient evidence to support Jada's belief that the true green counter proportion is greater than 2. Sorry, 0.2. Yeah, because she believes it's greater, but it's not significant here. Like the value is not less than. It should be less than if it's to be significant, right? Okay, and state the p-value for the test. So the p-value in this case would be this guy, right? That's the p-value then. So this is the p-value. It's just the thing that you compare with the level of significance, right? Okay, there you go. And part II, find the acceptance region for the test in part I. Well, acceptance region, right, is basically a critical region. Is the region where if it's not 11, to make it critical so that you reject no, what would it be? Yeah, so basically critical region. Now we want the right tail, we want the greater side of the distribution, right? So we're gonna have to use, this is 0.2, yeah, so I can use the table. So let's look at the table. So we have n of 40, right? So I'm gonna go down here 40, yeah. And then probability of 0.2. So we are looking at this column here, yeah, this column here, you see my cursor. And we're gonna use, so this is the right tail. I draw bell curve all the time, but it's not exactly the bell curve, therefore binomial, right? Because it's discrete. So we want this area to be 5%, to be just critical, right? That means the remaining area, which is the left part here, is 0.95. So this critical value xc should be the one that when p of, so basically we want to find p of xc greater than, p of x greater than the critical value is going to be greater than, less than 0.05. Yeah, so this is saying that if you go above or equal this, the probability of that should be less than 5 to be in a critical region. That means we want some value, one less than that, because when you do the other side here, which is this side, you got to go one less here because this is discrete, right? And the probability should then be the opposite, which is greater than 0.95. Yeah? All right, so make sure you understand that, why I do this. Because I do this because the table only offers the lower tail of the distribution. So we need the one that gives me greater than 0.95 for this one, yeah? Which is this guy. Okay, it's that guy there. This is probability of 0.2, and when x is 12, we have that. So I need to write like this. So p of x less than equal 12 first, maybe, is the one we want. But then you need to show some working. So I need to show the first one, maybe. So it's the one that is less than that. So this one equals 0.9125. Yeah, just the one above. Because this is not quite over 0.95 yet, so we got to use this one. It's just the smallest one that we can use, right? Smallest one that we can use, yeah? Okay, so that means the critical region, xc, should be this plus 1. Because don't forget that the one that we found, the 0.9568 here is this area. But it's just that. If you want the actual critical region, you just have to go to the right by 1. Because it's the opposite side there. So xc there should be 13. That means the critical region would be x greater than 13. That's the acceptance region. So that's why 11 wasn't critical. So that's why 11 wasn't there to make us reject the null hypothesis. Yeah. So that's it. This is the answer to part II. Okay. All right. So number 4. I think we have time for the other part. We have how long do we have again? Is it the whole paper 2 hours, right? So this is how many marks? Total marks 30. Was it? Okay, I'm gonna finish this as fast as possible. I'm not sure how long I have, but I'm thinking maybe 2 hours, but that shouldn't take long. All right. Okay, 4. Giovanni, if I pronounce that right, believes there is a relationship between the mass of a car in kilograms and its fuel consumption, C miles per gallon. For example, of 25 cars, he obtains the following summary statistic. A, find the standard deviation of the fuel consumption of the 25 cars. Okay, standard deviation, when you have, this is called the sum of square of the difference, sum of the square of the difference, okay? Standard deviation, okay, let's talk about variance, right? You might already know that variance is the sum of x squared over n, that's the mean of squares, minus the square of mean. That's variance. But the other formula, right, is when you sort of like combine that to one single term like this and divide everything by n and find the square. We don't find the square root. Actually, let me check. Hang on, I forgot to open back up the question paper here. Okay, so let me go back to the formula sheet and show you that they give you the formula. Interesting. That's correlation. Yeah. Wait, no. Should be somewhere here. Okay, here. Yep. So this is basically x minus mu is x minus x bar. This is variance. No, that's not useful. Hang on. Let's do this AS. This is probably A2 level. Hang on. Sorry. Okay, you probably have to realize by yourself that. Okay, there you go. Sorry. Yeah, there is. So basically, standard deviation. Yeah, this formula, right, is the one that I told you. The first one I told you there. But do you see that if you check SXX here, I mean, sometimes they give you useful information, but sometimes they don't. Like they give you information where you need to process it. It's not like readily digestible sometimes. So here, they also tell you that this guy equals this guy. But what is this guy? How is it related to the variance, right? If you notice here, what is variance? Variance is that divided by n, right? Yeah. So basically, the SXX you see is variance. I'm going to write bar x here times n actually, right? Times n, because when you divide by n across here, you're going to get the variance. So when you divide these two terms by n, sigma x here, both of them will have one n dividing. So each of them will then become x bar because that's sigma x over n. Yeah, and you have two of them, so that would be x bar squared. I'm just saying that this side, then you would also have this divided by n as I have here. Okay, so variance is SXX divided by n. I'm just saying that, yeah? That's basically what I'm saying here. Variance is SXX divided by n. So that's why we got this one. All right, I hope that's fine by you. And let's get back to the paper. That means standard deviation is going to be equal to 394. That's the thing we want there already. Divided by the total number of data, which is 25 cars. And we're just going to take the square root because that is the variance. All right, so square root fraction 394 divided by 25. 3.969. I'm just going to do 970. 3 decimal places, yeah? Okay. Okay, yep. Let's put some units in as well. So what's the units? MPG, all right? Yeah. Using M as the explanatory variable, Giovanni creates the linear regression model, where A and B are constants. Using his model, he concludes that, and on average, the fuel consumption is 3.5, lower for each additional 500 of mass. Right. So that is basically telling you the gradient. Yeah. For each additional 500 kilograms, so that's M is the explanatory variable. This is the independent variable, I think. Yeah, and C is the dependent variable, which is the fuel consumption. So it's basically saying to you that delta M is 500 kilograms. This is part B. Yeah. And you would have delta C to be 3.5, right? Yeah. The fuel consumption of the car with the mass of, yeah. So we're just going to use this to find the gradient, and the gradient is the B there. So if you map this to y equals mx plus c, that's a linear equation. So the y would become the c. Sorry, excuse me. The y would become the c, and the x would become the m in this case, right? So b, which is the gradient, don't confuse with the m there. Yeah, b and m. I think they try to confuse you here, basically. So b, which is the gradient, is basically delta y, which is delta c, over delta x, which is delta m. Yeah, gotta be careful there. Oh, but it's lower. We gotta be careful. This is lower, so minus there. Okay, that's the gradient. Minus 3.5 divided by 500. Minus 0.007. Okay, and then, oh, we got the value of b now, right? Yeah, part I. And then the value of a, so we plug everything back into the equation. We get c equals a minus 0.007, was it? Yeah. Let me check. Yeah. Times m. And we have another line of information there. Consumption of the car with a mass of 17,000 kilograms. That is the m, right? If we plug m equals 1700, and the c will be 20, and we sub that, we're going to get a. So a is equal to, that would be c plus 0.007 m. So c plus 0.007 times 1700. Yeah, so we can use a calculator there. 20 plus, right? Yeah, 0.007 times 1700. Just checking. That's 31.9. That would be the answer there. Okay. I'm just checking everything here, guys. Yeah, that should be fine. Let me just check my calculator here. All right, that's it. That's it for part B. That's done. Number 5, last question in statistics. Events A, B, and C are such that PA or C, that is to say PA union C, yeah, equals 0.55 there. The probability that none of the events occur is 0.23. All right, I think we got to fill in the, let me just draw it quickly, yeah, the Venn diagram here. All right, for the sake of explaining too. Okay, so we have A, B, and C. The probability that none of the events occur is 0.323. Okay, so that means U is 0.23, right? None of the events. the probability that exactly two of the events occur, so it's either P or S. Sorry, Q plus S is 0.18. Well, we already answered part A, right? Because it asked for U here. Part B, find the value of R. All right, so we're going to carry on. The value of R is about, oh yeah, sorry, nothing. Value of R is in B. Only B. It's only B there. Okay. Probability that exactly two of the events occur is 0.18. We already got that. And A and B are independent. So that is to say PA times PB equals PA intersect B. That is the definition of being independent, guys. You need to know that, yeah. Let me just fix the glitches here in my head. I don't quite like that. Let me just fix my head a little bit, yeah, if you don't mind. Just reduce the level of that a little bit. Okay, I think I'm okay now. Yep. Find the value of R. Yeah, okay. So PA, okay. They also tell you that PB is PA plus 0.1. So we're going to sub that. So we have PA here times PB is given to be PA plus 0.1. And PA intersect B is the Q, right? Interesting. All right. Okay, so they ask you to find the R. PA 2 marks. That shouldn't be hard. Okay. So I forgot to use the information that PA or C is just these whole lot of A and C. These two add up to 0.55, right? Okay. Now you visualize that because don't forget we already have the U to be 0.23. Yeah. So if you add the 0.55 and add 0.23 here, the remaining should go to R because that's the only area left unconsidered here. Yeah, so nothing hard about this. Actually, I'm just going to keep that for later. It's not this part. So part B is just 1 minus 0.23, which is the U, and the whole lot of A and C, yeah? So that's going to be what? 1 minus 0.78, so that's 0.22. 78, yep. Okay, so that's the value of R, right? 0.22. And then part C, we got to find a lot of things, right? Okay, so we already found R. P, Q, S, T add up to 0.55. We know that. And we want to find all of them here. Okay, see what we have here already. We don't have S. So how is it knowing R will help us find the remaining? Okay, so I'm going to rewrite that again. Hi guys, just a quick one here. This statistics always blows my mind. So as you can see, for the past 28 days as of today, out of all the 7.7 thousand watch hours, more than 90% of those watch hours come from those of you who aren't subscribed to my channel. And that gives me an urge to beg you, please help support me by subscribing the channel. I will return this huge favor by creating more and more videos. I'm going to utilize my teaching experience for 10 plus years to create the videos covering tips and tricks and the hard bits in the topics that most students struggle to understand. It can either be a short video, a long video, but they will sure come up. So that is why you need to subscribe to stay tuned. I hope we have a deal. Let's get back to the walkthrough. Q plus S here is 0.18. Yeah, probably of exactly 2 occurs. Yeah, that's Q plus S. But then P and A and B are independent. So that means PA, which is P plus Q, times PB, which is, that's horrible. Oh, PB is PA plus 1, right? So we're just going to do PA, which is P plus Q, and then plus 0.1, sorry, equals PA intersect B, which is Q, right? So that's another equation there from being independent. And I also use two pieces of information here. Yeah. So let's see how that's going to help us find the other part. Oh, and I forgot that, no, we already have that. So PQ, we also have another one, right? Where P plus Q plus S plus T should be so 0.55, right? Because the U and the R is just the remaining. It's the opposite to what I have here. So this plus this plus this would also be 1, right? Yeah. And we have that equation. Let's see. So Q plus S is in here. P plus T. Is that useful? I mean, we have this equation here where we have P plus Q, which is this guy. Let me see. We have P, Q, S, T. Q subtract this would... I might be missing something here. Let me just check. None of the events occur. That's already U. Exactly 2 events, Q and S. How are we going to use Q and S? A and B are independent. I mean, I don't want to expand this, but if that's the last resort and it will help us, then why not? See if it's actually helping us. Okay, yeah, I'm going to try expand that. So it is basically just P plus Q. So if you look at this as a whole group, right? And this is P plus Q as a whole group plus another thing. So basically it's going to expand this whole thing to this and this whole thing to 0.1. So that makes it this plus 0.1 P plus Q like that. I don't want to just go expand like 3 and 2 terms there. And this will be P plus Q squared plus 0.1 P plus Q minus Q equals 0. Yeah. Well, P plus Q is basically PA, right? Oh, hang on. Yeah, I think we should do in terms of PA. So this is PA. So let's make that PA. PA squared plus 0.1. Okay. But we don't know Q. Right, guys. This one is troubling me. What am I missing here? So, okay, let's subtract Q plus S to this. We get P plus T, yeah, to be 0.55 minus 0.18. That is just 0.37, yeah? That's just P plus T. Oh, wait. Okay. I got something. Okay. P plus T is the thing outside, right? So if you consider you have P plus T, if you plus that with U and subtract from 1, you're going to get B, right? So that is PB equals 1 minus P plus T plus U. You're going to get PB there. Didn't see that coming. Sorry. 1 minus 0.37 plus U, we already know that, which was 0.23. So that is just 1 minus 0.6, which is 0.4. That means PA is PB minus 0.1, which is 0.3. Yeah? That means PA intersect PB, right? Which will be this times that. So PB was that, PA was this, is 0.12, and this will be equal to Q. Right. So what was P again? Okay, hang on. We gotta order this. So P plus Q is A, yeah? So P should be PA, yeah? So P is just the remaining bit of PA, so it should be PA minus Q, which is, what was PA? PA is just 0.4, right? Wait, what? PA is 0.3, sorry. 0.3 minus 0.12, that's 0.18. So I got a P here, yeah? And I got a Q here. So this is I, this is II. And then I got an S, right? So an S is, what is an S? An S is basically, because we already know Q, we can get an S from here. So S is 0.18 minus Q, which is 0. No, not 0. What was the Q? The Q was 0.12, sorry. 0.18 minus 0.12, that's 0.06, isn't it? And then IV T equals, well, T we got from P plus T equals 0.37, so that's going to be 0.37 minus P. Minus P, P is 0.18. So T is 0.19, yeah? So I got all of them there. Lucky me, I saw that. So you see, you just have to look at a different aspect here when you are stuck, right? That's the tip there that you should get. See? I'm not perfect, so sometimes I don't know what to do. And that's it for statistics. Now let's do a mechanics. Yeah, I'm just going to change the paper now. I think we should have time. I mean, assuming that like it's 2 hours, yeah? So if it's 2 hours, I should be fine. But where's the paper? Hang on. Let me find the paper. Okay, here we go. Yeah, I got the paper now. And then I'm gonna just change this to, where is it? I have a problem with my technical problem here, guys. I can't seem to find okay, there I got it. So we're gonna do okay, this one instead. Yep. So that's the mechanics part. It's unofficial, so it's not a proper paper yet, yeah? Yeah, because I got it like this. So mechanics, number 1. Figure 1 shows a sketch of the speed time graph for a model of motion of a runner traveling along a straight horizontal road from point A to point B. The distance from A to B is 400 meters, right? So from A to B, distance traveled is the area under the speed time graph, yeah? And everything else here is just explaining the graph, I think. Yeah, traveling constant speed, moves constant deceleration for 15 seconds, okay, until it comes to rest at B. Traveling A to B in t seconds, find the value of t. All right, so for A, right, you need to find just the time t here. Now, we need to find the total. No, actually, we need to find, hang on, let me think about that. 400 meters. Okay, acceleration. So let me just draw that out. So let's do t1 here. And this is the speed of 5, right? Okay, so t1 would be the time taken to accelerate from 0 to 5. Yeah, so basically acceleration is delta v over delta t, right? Change in speed over change in time. So that means time t1 here is just the change in speed, which is 0 to 5, which is 5, divided by the acceleration, which is, oh, it doesn't tell you, right? Hang on. Okay, fine. Interesting. Okay, so I think we need to find this time here. Okay, so let's find this delta t, because it tells you that it takes 15 seconds, then moves with a constant deceleration for 15 seconds. So that's delta t is 15 seconds here. I want to find the, wait, 15 seconds? Oh, hey, hang on. I'm a bit confused here. Then moves with a constant deceleration for 15 seconds until coming to rest. Yeah, so it's telling you the deceleration, nothing much here. So we know that this is 15. Okay, that's fine. This is 15, but we don't know the other part. Oh, so this is 5 seconds. Sorry, must have been blind. It must have been blurred from that Venn diagram question there. And yeah, so accelerated for 5 seconds, and then constant speed, and then decelerated for 15 seconds. And yeah, okay, so 1 over 2 times height times the area, sorry, the sum of parallel sides here. So let's say this one is little t, then I'll make it delta t, yeah, this one. Yeah, so it would be delta t plus 5 times plus 15 plus delta t. So basically we're adding up this bit and this whole bit in the brackets here. And that should be equated to 400, yeah? Don't know why it took that long to think this. So if you solve this, you should get 40 on the left side, because that's basically 800 divided by, no, that's not 40. I gotta be careful here. So 5, cancel that, is 80. And this is 160, yeah. And that would be equal to 2 delta t plus 20. So the delta t, which is the time taken for constant speed, is just 140 divided by 2, which is 70 seconds. Okay? That means t is the whole time taken here, would be 5 plus delta t plus 15, which is 90 seconds. Yeah? All right, so that's part A. Part B, state one reason why the actual time taken to travel from A to B might not be t seconds. So it doesn't say about friction, right? Let's see. The motion of a runner traveling along a straight horizontal road from point A to point B. Distance from A to B is 400 meters. The model of the motion is that, yeah, the acceleration might not be constant, deceleration might not be constant, it can change, right? Because this is a human being, we can't accelerate always uniformly there. Yeah, so acceleration may not be constant. I'm going to go with that. And the constant speed part may not be at always 5 meters per second. Yeah, I'm just gonna write that. Yeah. Well, let's just choose one reason. So the best one is just that, maybe acceleration may not be constant. Yeah, let's just do that. You know, I'm gonna go with the other one because it's more dominant here. It's the major part, the constant speed. Yeah, okay, I'm gonna go with that. Number 2. A particle P has mass 0.25 kilograms. The particle moves on a smooth horizontal surface under the action of 2 horizontal forces, F1, F2, as vectors I and J there. Find in terms of I and J the resultant force acting on P. So we just have resultant force acting on P. I mean, do we have to consider weight here? Particle moves on a smooth horizontal surface under the action of 2 horizontal forces, F1 and F2. I and j. So I is just due north, j is due east maybe. So yeah, probably not. I overthink too much maybe. Okay, so it's just F1 plus F2. That's the resultant force. Yeah, it's just 3i minus 5j plus minus 6i plus 9j. So that is just minus 3i plus 4j. Yeah, that should be easy. Newtons. And B, find the magnitude of acceleration of P. So A equals sigma F over M in this case is just the resultant force divided by M, which is 0.25. So dividing by a quarter is like multiplying by 4. So that's minus 12i plus 16j. Yeah, just multiply out by 4 there. And we want, this is the acceleration vector, but we want the magnitude. So absolute A here is just a Pythagoras of 12 squared plus 16 squared. And that should be 20, isn't it? Because that is 3 and 4. Yeah, it should be 20 if you try it. I mean, I can try it just to be safe as well. Yep, I have a trick there. So that's meter per second squared. Part C. A third horizontal force F3 is now applied to P. Under the action of all the forces, the particle moves at a constant velocity. So F3 is balancing the previous resultant force. I mean, look, if you have F1 like this and F2 like this, yeah, so the current resultant force will be acting, just going to use a bright color here, to this direction, right? Something like that. Okay, let's say that is the current resultant force, this guy right here. Okay, now, but if you add another force, now you need to understand first that when it says constant velocity, it means the resultant force is 0. So how do you add another force to balance that R? You gotta add the opposite force, right? Yeah, so this is F3. This diagram is to explain you that F3 must be opposite to R to balance this whole thing. Okay, so that's it. And the R we already got in the part A. So F3 is equal to minus R, which is 3i minus 4j. And that's the logic there. 3i minus 4j. Give me your answer in terms of I and j. Yeah, I did it. Yeah, you okay with that, right? Make sure you're okay with the logic there. That's why you got the opposite to R to make it balanced. Yeah. Number 3. Okay, I think I'm going to be good with mechanics here. Okay. Yeah. A package P of mass 2 kilograms is held at rest on a horizontal table. One end of a thin rope is attached to P. Yeah. The rope passes over a pulley. Yeah, it's going to be a pulley like that. And then like that, I guess. That is fixed at the edge of the table. The other end of the rope is attached to a packet of mass Q that hangs freely. This is Q, hang freely, 3 kilograms below the pulley. And this is package P, yeah, of mass 2 kg on a horizontal. Okay. Package P is 1.2 meters from the pulley. Okay, 1.2 there. Package Q is 0.4 meters from the floor. And the rope is taut in figure 2. Oh, they give you the figure. All right, yeah. Okay, I didn't see that. Fine. Yeah. Package P is released from rest and Q moves downwards, of course. The table is modeled as being smooth, right? Packages are modeled as particles, okay. Air resistance, negligible. Pulley is smooth. Rope is modeled as being light and inextensible. So there's a lot of modeling assumptions here. I think later, yeah, they will just make you criticize or explain the refinement of the model. Part A, write an equation of motion for Q as it moves downwards. So move downwards, so acceleration is going down. This is connected particles, right? So if we consider the mass Q, right? We have the weight 3g, which is mass 3 kilograms times the g. And the tension, yeah, you have a tension upwards and also the tension to the right of P. So that is just the equation of motion. Yeah, making T the tension there. Does it say tension beforehand here? No. So we do 3G minus T equals 3 times A. Yeah? The equation of motion of Q as it moves downwards. Yep, equation of motion is like Newton's second law basically. I'm just checking if we are like overlooking any information here. I don't think we are. Yeah. Okay, find the acceleration of Q as it moves downwards. That means we need to find from the other part as well. Yeah. G is 9.8. Yeah. So the other part is when we have a P, right? So T, the table is smooth, so there's no friction there. It's just going to be T equals to A. Yeah. 2 kilograms times A. So if we add those up, right? If we add up the two equations, so it's 3G equals, we add this up. So we get 3G minus T plus T, T goes away. And then we have 5A on the right here. Yeah? So A will be 3 over 5G. Well, let's make that a decimal. 3 over 5 times 9.8. That's just 5.88 meter per second squared, right? Okay. And then that's A, part B done. Part C, find the speed of Q at the instant when Q hits the floor. We have acceleration already. Yeah, we're going to use it. We have distance. This is suvat, guys. So suvat, let's bring it here first. Distance traveled is 0.4. Let's do downward as positive convention. So moving down, 0.4, right? Yeah. Let's look at the actual diagram here. And then U is 0. V, we don't care, we don't know. I just gonna do that. A is 5.88 downwards. And T, wait, what do we actually find here? Actually, we want to find the speed. Oh, we actually want to find the speed. So we care about the speed, sorry. But we don't care about the time. So what equation here? Is the one without the T, which is V squared equals U squared plus 2AS, yeah? So that's U squared plus 2 times 5.88 times S, which is 0.4, right? Yep. I'm just checking my value of A here, just once again. Yeah, so you're going to have to square root that, right? So square root 2 times 5.88 times 0.4. Is it 0.4 for the distance? Yep. So that's going to make it 2.16887, blah, blah, blah. I'm going to make it 2.17 meter per second. Yeah. That's the speed of Q when it hits the floor. Part C done. Part D. Given that K seconds after Q hits the floor, P hits the pulley. Use the model to find the value of K. Okay, so we assume that when Q hits the floor, yeah, they will be no longer connected. Okay, which means when Q is here, maybe P is around here. Actually, we know exactly where P will be. So it will be 0.4 further to the right, and Q will be on the floor. And when that happens, the string will become slack like that, like not taut. That means P will move with an inertia, but no acceleration. Okay, no acceleration, no deceleration. Why? There is no resultant force now because the only force acting on P before Q hits the floor is the tension. If they are no longer connected, there's no tension, so there's no resultant force. So V is a constant value. Okay, there you go. So that means from this part to hitting the pulley, we consider P as moving at a constant speed, right? So the remaining distance will be 0.8. We just have to find the speed of P first. And the speed of P should be the same as the speed of Q when Q hits the floor because they are connected. The A, the T, and the S are all the same. Acceleration, velocity, and displacement are all the same, but in their respective directions, right? So if moving down here, the speed of Q hitting the floor was the answer to the previous part, 2.17. Then the speed of P at that moment is the same. Yeah. So Vp is equal to 2.17 here. That means the remaining distance, T, is just distance over velocity. Yeah. So distance move 0.4 already. So we have remaining 0.8. Yeah. So that's just 0.8 divided by 2.17. Okay. So I'm going to do answer that. And then 0.8 divided by answer. Yeah. Okay. Which is 0.3688, blah, blah, blah. I'm just going to round that to 369. Yeah. So that's the time that P will take to hit the pulley. And yeah, that's exactly what K seconds is, right? After Q hits the floor. So K equals that, basically. Yeah. In the refinement of the model, there is a resistance which acts against the motion of P. This refined model is now used to find the acceleration of Q. Acceleration of Q is the other one, right? Yeah. As it moves downwards. State with a reason whether this new acceleration will be greater than, equal to, or less than the acceleration found earlier. Well, if there is a friction, right? Yeah. There is a resistance or friction, well, then you have something subtracting this equation. So this will be T minus some F, right? And then when you add up these two equations, you would also have some subtraction here. Yeah? And that would make A, which is the acceleration, smaller because you would then have 3g minus F divided by 5. So basically the resultant force pulling particle P to the right is less when you have friction, and that is effectively affecting the whole connected system because there is some resistance there. So we just say less than that in part B with a reason, because of a smaller resultant force to either to both particles. Yeah, I would say to the system, maybe to the system, because they are connected. So let's use system. Yeah, smaller resultant force is the keyword. Okay. F suggests one further refinement that could be made to model apart from including air resistance. That would make the model more realistic. Guys, actually, if you know this trick, is easy. Whatever the assumptions that they have used earlier, that is how you refine the model, right? So being smooth here is the table, so that's not counted because that's already accounted for in E. Yeah, because in E you have a resistance. Now, where does this resistance come from? It's from, the table not being smooth. So the first point here is taken. We can't take it. Packages are modeled as particle. Yeah, you can take that. Air resistance, not gonna work because they say that apart from air resistance, so we're not gonna take the third one here. Pulley modeled as being small and smooth. Yeah, so we can say pulley, consider the mass of pulley and the friction from the pulley. That also works. Or you can say about the rope, consider the mass of the rope because it was assumed that the mass of the rope was light, and extensibility of the rope because it was assumed that the rope was inextensible, right? So we can write a lot of things, but we're just going to write one. I would say, yeah, pulley, right? I would say pulley is the key one. Yeah, so we say pulley has, consider the mass of the pulley, mass of pulley, and that it has friction with the rope. That's it. So we can say that, yeah. Number 4, yeah. Oh, that's it, yeah. I think I'm gonna, yeah, be before 1.5 hours. Number 4, a fixed point O lies on a straight line. Particle P moves along the straight line at time t seconds, t greater than or equal 0. The distance s meters from P of P from O is given by that straight line. Okay. Find the values of t for which P is instantaneously at rest. Because s is distance, so we need to differentiate the s by dt, because that would give us the speed. So we equate it to 0, and that is where we want the answer there. So it's just 3 multiplied 2, we get 6t squared, minus 2 multiplied 12, we get 24t plus 18. We equate that to 0. I'm just going to simplify by 6 first, so I get this. And then I'm going to factorize that, yeah. So this is minus 1 and t minus 3, basically. So t equals 1 or 3. The values of t, yeah, that's done. Part B. Find the total distance traveled by P in the interval 0 to 4. Well, if we plug 0 in, we get 0, right? If we plug 4 in, we get... It shouldn't be that easy, right? It shouldn't be that easy. Okay. I see. Okay, you know what? I'm just gonna plot this whole graph first to see, because it's 3 marks, so that's bugging me a bit. So I'm just gonna take 2t out, and that's gonna be t squared minus 6t plus 9. Yeah. Can I factorize that? Yes, I can. So 2t, t minus 3 squared, right? Yep, buddy. Yeah. So if you plot this st thing, you get 0, and then it's gonna look like this, because this is cubic. You should know how to plot this, yeah? This is in pure 1, of course. You have 0 there and 3 here, because this is a repeated root, so you have a turning point touching that. Right? Hang on. Oh yeah, and that's why this is 1 here. We know that that is 1. That is where the turning point is. And this is 3. Alright, that makes sense. That confirms the answer to the previous part. But we want the total distance traveled from 0 to 4. Aha. So from 0 to... Okay, and this allows us to see that distance s meters from P to... Oh, okay, this is basically displacement. The origin is where you start, and P is particle. So that's why it can decrease. It's the displacement here. Don't be tricked by this wording. Because you see, S can be greater or smaller. It can decrease or increase. If it was a distance traveled in the first place, it couldn't decrease. It could only go up, right? But this is displacement. So we want to find this amount, yeah, and this is where it goes back, and this is where it goes up. So this is tricky. So we're gonna split, right? So we're gonna have to do s from 0 to 1, plus s from 1 to 3, plus s from 3 to 4, because we find total distance traveled. Now for s0 to 1, we just sub s1 in. So s1 is just equal to 2 times 1 to the 3 minus 12 times 1 plus 18, 1. So what's that? Let me just check here. Yep. So 2 minus 12 is 10, minus 10, plus 18 is 8. Yeah? Is that right? Yep. Happy with that? Yeah, so that's S0 to 1. Right? And S1 to 3, right? Okay, so we know that S3 must be 0. That means S1 to 3, to make it make sense, this is 0 displacement. So you have traveled up to this point by 8 meters. And you want to go back to the origin. So you would have traveled by 8 meters as well to go back, right? So that's 0 displacement, this distance traveled from 1 to 3 as 8 meters as well. English is not my first language, sorry, yeah. But I hope you guys understand so far, yeah. And then 3 to 4. Well, 4 is around here, isn't it? So we should find the S4, and that will make it 3 to 4 already. So S3 to 4 is actually S4 because you go from 0 here. So whatever value we get from substituting T as 4, that is going to be the distance traveled from 3 to 4 seconds. Yeah, just look from the graph there. So that would be 2 times 4 to the 3 minus 12 times 4 to the 2 plus 18 times 4. I'm just checking the substitution here. Yeah, and then plug in the calculator. 2 times 4 to the 3 minus 12 times 4 plus 18 times 4. Wait, what? No, 4. Okay, here we go. Is that? Yep, 152. So we add them all up, right? So total distance traveled is equal to 8 plus 8 plus 152, 168 meters, right? Meters, yeah. Yep, so let's call it that. Part C. Find the maximum speed of P in the interval 1 to 3. Maximum speed, maximum gradient. Okay, so yeah, we need to take the first derivative here, guys, and differentiate it again, basically. So dv by dt is d squared s by dt squared, just basically the second derivative of this guy, and equate that to 0, basically. So differentiating that thing, just this thing, yeah. So we get 12t minus 24, right? And we're going to equate that to 0. Because it's like, after you differentiate the distance, you get speed. After you differentiate the speed, right, you're going to get acceleration. And speed is maximum when acceleration is 0. Just like when you find the turning point of a function. So let's call this the gradient function of the speed. And you're going to find maximum speed when you equate the dv by dt. I mean, look, ignore this, yeah? You want the maximum speed, right? That's why you do dv by dt equals 0. Yeah? Imagine you start from a speed time graph. You want to find the maximum speed. You differentiate, put it at 0, and that makes t equals 2. Right? And if we want the maximum speed, then v at t equals 2 would be, just substitute 2 back in the speed equation there. So that's 6 times 2 to the 2 minus 24 times 2, yeah, and plus 18. That would be the answer there. So that's 24 minus 48 plus 18, right? Interesting. It's negative. All right, now. Is it negative? Looks like it's a negative value there. So maximum speed occurs. So this turning point is where velocity is negative, yeah. So therefore maximum speed is 6 meters per second. It's just at when it's going backwards, right? That's the maximum speed. Just gonna say 0.2, 0.0. Let me check my working here. I think I'm okay with t equals 2 there because we get a positive answer there. And when we plug 2 in there, yeah, we get 24 minus 48, that's minus 24, and plus 18 would be minus 6. Yeah, I'm gonna take my chances there. And that's it, guys. I hope I'm within the time limits. I'm not sure if it's 1.5 hours or 2 hours, guys, but I'm gonna stop the timer there and mark the paper, yeah? Okay, guys, I'm back. And I gotta say first that I literally didn't know the time limit of the whole paper. It was actually meant to be an hour and 15 minutes. I thought it was like 1.5 hours or something. So I do apologize for that, but I spent like an hour and 21 minutes, so I hope you guys are okay with that. So I'm not going to be, too proud of what I did here, like in terms of the marks, but I made quite a few mistakes, and we're going to go through it, yeah? I hope you already see in the annotation as well. So the first one that I got wrong is this one. So this is the large data set thing. Everything is fine up until the last one, part C. I got the number of days right, I think, because as of the time of recording, there's no official mark scheme yet. So we do refer to from May to October, and that's the total of 184 days. So if you subtract that, if you take away 161 days out, because there are 161 days from the light days, the moderate days will be 23 days. But then we need to do multiply by 0.25 here, because I forgot totally that this is important, because we only take the number of days that is greater than 1028 hectopascal, which is the, greater than the upper quartile here, basically, because 1028 hectopascal here is at the Q3. So that means the higher data points than this value is going to be the, top 25%, yeah, of the whole data. So that's why we need to do 0.25 multiply, and the estimate is about 6 days. I think that should be okay. Number 3, yeah, the first one, distribution, didn't quite nail that one. I got the probability right, but then I'm gonna take away 2 marks here, because the distribution of number of reds here means that we need to do like we put it to statistical distribution. I should have known. When you see the words distribution, it's either binomial, normal, uniform, just pick one, yeah, or the whole sampling distribution, depending on the question. But in this case, we know that it's binomial for the red, because the probability of the red is 0.16, and then that should be the 2 marks there that you get. So I'm just going to take away 2 marks here, just to be fair. And the remaining is fine. Yeah, the p-value was right, 0.161 there, and hypothesis testing here is okay. Except this one. I was wrong about the acceptance region being the same as the critical region. I misunderstood. I was mistaken. So my apologies on that one. But then the actual acceptance range, the region, is actually the opposite to critical region. So that's why the answer should be the opposite, the other side of x greater than 13 or equal 13. It should be x less than or equal 12. Yeah, it's just the other part of the critical region in the same distribution, right? So that's the acceptance region. Yeah, all right, so it should be that. So I -1 there. And yeah, everything else in stat is fine. And for mechanics, let's put mechanics up. Wait, what? No, that's me. Okay, so mostly mechanics also fine, although I spent quite some time on the first part and I ran out of time actually. I went over time by 7 minutes there. Everything was fine up until this one here. I am not sure what happened up until now. I haven't checked the video, so I got the wrong value here from the calculator. So I rechecked it again, and that should have been 8, not 152. So the whole thing's collapsed here. The answer should have been 24, right? Because you have 8 plus 8 plus 8 there. Because I got this one wrong. So there was a follow-through step there. I got a method mark, so I just lost one final accuracy here. Yeah. And then that's it. That's the whole thing for correction. So I do apologize. I went over time. And that's not going to happen again because I didn't know the time, the duration, the time, the allowed time for this whole paper. And let's do an overall review for the whole paper and each question. I think this paper is tough on the statistic part. The mechanics is fine. Yeah, mechanics I think is fine. Let's do statistic first then. All right. So statistic, yeah, this paper. Well, yeah, this one is fine. You got a calculator, you know how to do it. So I think this one should be okay for most people. Should be like a place where you get marks. Well, for question 2, yeah, you just need to know the word. It's census, yeah, census, right? Just get the name. And for the other parts, I think mostly fine. Whisker and box plot and whisker diagram here. And it's just the large data set here that you need to know. So that's the basic knowledge from the large data set. Do check the video that I made on the large data set. It's the holistic view of all the important points with some example questions from the past papers. Just so go check the video, yeah, large data set. And yeah, so from May to October, there are just 184 days. So if you subtract 161 from 184, you should get the remaining day here. So that's where I went wrong as well, because I didn't read that it's actually the upper quartile to the higher end there. So I got it wrong there, that one. So this is tricky. Yeah, it's tricky. It's a bit tricky here. Number 3, yep. Couldn't have got this one, right? I couldn't have seen it because, yeah, I thought the word distribution there is just the probability and the expected number. So I went in there totally a different aspect there. Didn't get it. So that one is important. So distribution here. I mean, if it says probability distribution, I might have got it. I might have tried something like this. But just the wording is a bit, I'm not going to say vague, I'm not going to blame it, but it's just me that didn't have experience seeing this word, so that I know that I had to do this. Okay, so there you go. So I guess I also learn every day, yeah? All right, and this whole part is, yeah, it's fine. Hypothesis testing using binomial, so you just need to know that the word p-value is just the probability you use to test against the level of significance. That's called the p-value, right? So because I calculate px greater than equal 11 to be 0.161, so that is why it's called the p-value there, okay? And yeah, I also learned this, that I didn't quite see the word come up. Acceptance range, acceptance region, just the opposite to the critical region. Yeah, normally we would be used to critical region, but anyway, this here is a bit tricky here. There you go. So just be careful on that. Yeah, and number 4, you just have to know that the formula for standard deviation can also be that divided by n and take the square root. Yeah, so standard deviation of the whole sample of 25 cars there should be just square root of 394 divided by 25 there. So we get that. And part B here, I think it's fine. Now, yeah, the tricky thing here is that, do you know how to use these information to get the A and the B from the regression model there, right? So you need to know, you got to be careful, because they try to trick you here. M is not the gradient, right? And you already should know that B is the gradient of the regression line model. A is the y-intercept, kind of, yeah? And C and M are just the variables there. And in this case, they use the term explanatory variable, which is the X, or the independent variable kind of thing, yeah? And if you can interpret this one, they give you changes of X and Y, basically. You can find the gradient, which is the B. And this one just gives you another point to find the other one, basically, yeah? This one, the key highlight here, I probably will add this in the compilation of hard statistics later. Actually, I haven't got that for the AS paper yet. All right, I might be doing that later. Okay, yeah, I should do that, right? Yeah, okay, so this one I didn't quite see first, that we can use the fact that like we can find PB first using just like the P and T there. So I was missing this key information. No, this one here, that I could find PB first, just by knowing that P plus T plus U is just 0.37 plus 0.23. Yeah, we got, but yeah, but you know, it would require that you need to find P plus T first, and P plus T is 0.37. That wasn't too obvious, actually. That wasn't too obvious. So I needed some time to just contemplate there, right? And that happens, right, in the exam. Yeah, when you take it, you might need some time. Okay, and I think everything was fine here. But try to go back and understand this whole thing again if you don't. And I mean, yeah, of course, when you see me walk through, you understand it's okay. But later on, I mean, if you see a similar question, you want to try practice by yourself first and see the answer later. But this one, you got a lot of information. So the key thing here is try to utilize all the information, for all the points here. So if you think you are missing, like, okay, this line here you haven't used sometimes. So when you encounter that, you should think, okay, maybe I'm missing something because I haven't quite used this one, right? But back then I was trying to use every line there, but still didn't crack it. But then when I looked at it from a different angle, like I used the Venn diagram instead, actually. So yeah, somehow it just popped up to me that I should find B first, and then I cracked it here. Everything was fine. Yeah. So I guess that was it for this one. And mechanics, yep, mechanics was mostly fine. I think I nailed mechanics. Regardless, I mean, if we don't consider the time that I went over a little bit. But this part took me a while. It's just, yeah, I don't know. Maybe I got a bit like overwhelmed by the statistic part, and this one slowed me down a little. And yeah. So for part A, it's just area, but you need to maybe make this some variable and solve the equation to find it. So basically just find the area of trapezium. Okay, and don't forget that they asked for the capital T, not the one you let something, yeah, not the delta T there. Yeah, this one you could answer acceleration non-uniform as well, as I mentioned before, but because this is the dominant part, so I went for it, because the accelerating and decelerating parts are not that dominant compared to the constant speed part. This one, I think the key is the last part. The last part is the key. So try understand this diagram again. Yeah, you could go back and try understand that again using chapters in the description. Why I put F3 as minus R? Because this is basically equilibrium. You need resultant force being 0. Yeah, so it's just that. That's the key part there. For this one, a little texty, but it's just classic connected particle. Yeah, this one comes up a lot of times, and you need to nail it if you see this one. But yeah, it's just that this k seconds thing is probably not that typical, because normally it would have been like proving that P doesn't reach pulley or something, where there is a friction on the floor. Yeah, would have been a friction on the floor, and you would have had to prove that the particle P doesn't reach pulley because there is a friction, so it would decelerate. But in this case, it's smooth, so it asks you to calculate the time taken for it to reach the pulley instead. That can happen, yeah, and it happens here for this paper. And yeah, everything was fine. Just use this T equals S over V equation there. And this one is just the logical thinking about the acceleration, because there is a smaller net force, so smaller acceleration. And yeah, I already gave you the tips for F here. Whenever they ask for further refinement, you got to be careful, because some of them might not be applicable. Like they already say that you don't use air resistance. That's what they're saying here. They already took the resistance on the motion P, right? They already consider that because they asked for further refinement. So this resistance is already the friction. So you can't use the friction on the table anymore. And there are other points. So I'm just saying here, the bottom line is whatever modeling assumptions they use in the question, those will be the further refinements you're looking for. Just go the opposite way. So if If it's saying that pulley is smooth, then you say, we consider the friction in the pulley. Yeah, something like that, right? Not that bad. And number 4, this one, this one is okay for the first part. You just have to know that instantaneous rest is when v equals 0 or ds by dt equals 0. And I did that, I got this answer. Total distance traveled, this is the highlight, but I got the number wrong, but the method was totally fine, so, gotta be really careful. Plotting the graph is suggested, highly recommended here that you do first, because then you see the whole picture of the motion of the graph. Usually, they only do polynomial here. They're not going to do like, okay, exponential, rational, linear, or square root, whatever. They usually do easy functions, and it's normally polynomial, right? So you know how to plot polynomials, Make sure you know how to plot at least up to quartic, up to quartic, because quartic came up in the AS Pure Math Paper 1. You need to know how to plot quartic, at least, just to be safe, right? And then maximum speed is fine, so we do dv by dt equals 0 and find the t, find the maximum speed. It was -6, but it doesn't matter which direction it goes, but we want the maximum. So the magnitude, which is the speed here, is 6. And that is the whole paper, guys. I hope that was all useful. If you have watched this far, I think you find it helpful. So why not give me a subscribe and check out other videos, and I will see you in the next one. Bye.